for this session. Okay, in this second week of the lab one, we're gonna look through the uh, activities about the what you can do with the pictures that you're taking. Raise your hand to see if you had any successful to taking some pictures. Are you able to take some pictures? Good. And hope if you are not, just start doing that as well, and hopefully we get some good. But if you didn't take it, just take this description that we provided here as kind of very general description and information tutorial, and also videos on the web assign gonna help you out. And also we're gonna share those tutorial are free on the YouTube, that on the Skynet. If you subscribe it, you can get it. But we're gonna share with you those later on. But let me go through the first step for the how we're gonna use those information. Any question about the taking the pictures or first part of the lab one before going forward? Hearing none, I will start sharing the screen. Okay. Here, as you know, when you open the lab one, you had the what to call it, this for uh, introduction, and background and procedure. We're gonna focus on the procedure week 2 that is related to the videos that is described here. But going back to this session, I think I emphasized this before last week, but I reminding you again, read these items importantly, because this activity is on the second week. For example, you're gonna observe many different objects like planets, moons, dwarf planets, deep sky object, and kind of Earth moons as well. But at the end, you have opportunity to upload the Skynet observation number you have. This is Skynet observation. That's the one that you see it if you have login on a Skynet. When you have, for example, active observation like this one. Let me go over, for example, Jupiter or Uranus. This is a Skynet observation number. Therefore, you go back here on the lab, you put that number, copy and paste this number here, and whatever you did it, and you may need it to upload, choose the file and upload on the that part of the things. And this program itself, they're gonna grade you. Grade is for the lab one is about 134. It doesn't mean that if you don't get, if you are a good student or good learner to get 134, but that's not true, because out of that different object, not all of them is observable during the next 2 weeks or 3 weeks. Therefore, if you get something like 60 or 70 or 80, that's going to be a very good number at, and also indicate that you did it successful, important information. Also, if you add some items here that indicate what you observe, for example, in here, although you see it very faint object and not comparable with the picture like the one that is taken by the satellite. But again, it gonna gives you a better indication. You see uh, a light cap, probably polar cap of the Venus. This area on the right side and left side is light, probably has no uh, is a very light features on the surface. Here is you see very darker one, and that's going to show different features that on the planet Mars as well, and also on the Venus. So for example, what you see about the what you call it, this kind of regular crescent that you see it. That's only one of the planet that you can see it crescent. Uh, do you know how many celestial objects we can see at the crescent from those? Any guess? I think the moon is obvious, and the Venus is another one. Whatever we see at the interior planets in the solar system, we may able to see at the crescent. like a Mercury, Venus, and the Moon. But the problem is that on the Mercury is very difficult because always it's very close to the sun and difficult to Venus. Therefore, only celestial object that we can see crescent from them is Venus and the Moon. Therefore, the other things, for example, on the Jupiter, you see if there is a red spot, you see it, you just identify it, or whatever alignment on the rings, you see, identify it here as well. But Uranus and Neptune, you don't see it much. It's kind of very faint, probably white objects. That's the item that normally you will provide this question, describe and discuss the detail that you see it on the objects. And that's a very good indication. For example, they provide here some cheat sheets as I explain it to you. Here, we don't grade this one, but this is kind of very good interactive way yourself with yourself and also whoever read it can understand what you see it. On the dwarf planet, also same thing. You're gonna identify the if it is observable, yes or no, what telescope you use it, and what the universal date time you use it, and time. It could provide more details that we're gonna go over here. And we measure the angular diameter on here. That's one of the objects that we're gonna hopefully look through today. But going back to the for getting this information, we needed to go to use Skynet. If you look through the Skynet, I wanna see one of the objects, for example, that I see it before. Let me go over. I do example. Probably. Let me see if it is Saturn. We see it here. When you open the Saturn, you see one item I notify. Whenever it says I completed, it means that the picture that's taking is good. But it doesn't mean that the picture is good enough for your post-processing. Sometimes there is a satellite passing by. Sometimes there is many different problem that is exists that I explain it here on the before. I think we did it when we review. Sometime you need to make sure that take care of object that you see it. Let me see on one of the procedure for example, this one, if you look through the procedure, observe the Skynet, you will see it sometime the picture is not very good. You have to redo it again. And here, a picture of the Jupiter goes or Saturn goes to the left side, and you're missing this part of the picture. Normally, the picture is better to be on the center, but not always going to happen. Sometimes focus is not good, blurry, shutter is not opening wide, good, and there is a bright object or something here, or some ant or insect or bugs is putting on the picture. Therefore, when you do that, then you have to go back, come back here, and you have to, for example, let me show it to you. I open this Saturn. Here, when you see it, the object, you open here, this JPG, you see the very good, and you can see it very little. We're gonna show how you can enlarge it and see it. But this picture sounds very good, no issue on that. Therefore, you don't need it to repeat it. But if it is issue over there, you have to resubmit it. When you click here, resubmit, everything is saved. You don't change anything. All the parameters that you identify and also the observation name. You can change observation, say Saturn moons resubmit or something like that to remember that what you did it. And here you see it, unfortunately, there is no visibility here. Therefore, you have to wait for several weeks or months to see if it is observable or not. But some other things like, for example, Jupiter's moons, if it is opening here, I see it. Let me see. It looks good, and therefore I don't see it any problem. But if there is a problem, then you resubmit. When you resubmit, everything comes from the beginning here, and then you click submit. But if you want to change something, you just go to the target. Everything is saved. You change the name and redo the. You see that it is observable because all the telescopes about the minimum height of the observation on the sky. Then you go to the one-to-one item, change, you don't need it to change filter, save and continue to the exposures and review. And then when you go there and everything is, you check it to see everything is good and submit. This is a procedure that we normally do for a resubmittal. But but we don't need it to submit. For example, we go back to the list. This is the one that I choose, Jupiter moons, and I check it here. There is several different methods that you can look through. This is a download JPJ. This is a download FITS file that has more data on it and is not compressed like a JPJ. And therefore, but to post-process, we have another program. We call it here AfterGlow. Do you see everyone here an icon of AfterGlow under this observation list?
Yes.
Yeah, okay. Therefore, you click on that. When you click on that, the next page comes. Next page, you don't need anything. Just click logging with the same Skynet credential that you have, username ID. You can identify username and password, but personally, I prefer to use it that one because I don't want to keep too many things in my mind and become very difficult to remember. Then I click this one, and then the new page comes for the what to call it, the this Afterglow. This is the Afterglow workbench. And over here, first time you opening, you don't see it anything. You don't see it here because I had this several times. I opened those and use this activity for various tasks. You see many things here, but you don't see it on this line or any item. You can filter from them. For example, you can, if you have many observations down the line, you can, for example, if you want to check Jupiter, you just put Jupiter here and you see whatever you have it here. Then you find clearly. Therefore, this is search engine here, filter list gonna help you out on this. And the first important icon is here is that you have to, if you don't have it anything open here, you have to start with this one, open for folder or files. And here save all the files, and this is close all the file, and this is kind of refresh file list. This is kind of very typical way to kind of consider any kind of setting. You can identify setting here, but I don't recommend here. Whatever setting is there, you can use all of those easier. First item is here, is open the file. When you click the open file, you see three filters. One is the sample, one SkyTech telescope network, and this is workspace. The first one, sample, it's if you click on that, it's kind of provided some sample example for educational purposes. If for different types, sometimes we have Skynet for Junior, Skynet's research, or VWS. There is a different institution. They created this kind of web page to teach people. JWS, James Webb Telescope, iData is another activities that we have, but we don't want to worry about any of them. This is kind of Astro 101 lab that we are here. We're going to go over later on this, but at the moment, you don't have to worry about those and worry. Therefore, when you open it, you have to go back, up, some files. When you click on the files, this is the main directory that you have. When you click any of them, it brings on here. If you click this one, you see file sample. So this is the directory of the location that you have. If you want to back to the previous location, you just click the files. You back the first location. Then here, you just another one is the Skynet robotic telescope. This is kind of where normally there is a group collaborative work available. You look through it. You don't have to worry about those, just for the sake of your information. And this is user observation. This is a user observation is the one that you have it. Therefore, you upload it. When you upload it from here, it's saved here. Therefore, to look through your own file, you go to the, let me go from the beginning. Click on this, click on the Sky Robotic Telescope Network and user. It means that your user activities. And here, observation that I did it, I can look through it and find the, for example, whatever I needed. For example, um, let me say, uh, for example, Jupiter, Uranus moons or Jupiter moons, anything here is available. Therefore, that's one of the way that you can access your file. And if you keep it here, when you upload it, it's gonna save it on this location, on this toolbar on the left side. Therefore, that's kind of very simple way how to get your data on the uh, AfterGlow workbench. Because I downloaded and after Informat or Skylake, I just click on that. When I click it, you see the first here, you don't see anything in black. You have to use kind of maneuver here, zoom in, zoom out, or zoom to fit. When you do the zoom to fit, you see the object is specified. You can bring it on the middle or enlarge it, whatever you need it. You can adjust the space, for example, here, just make it more extended here. Just zoom on the feet to make sure you have a good number, or you can close this one as well. When you click this one, you see on the right side, there is many icon that we're gonna go over on the next sections. But this is kind of display setting, and this is the information, and this is a kind of show custom marker that we're gonna go later on, and this is a plotter. And this is a 4 item that we normally look through it. The important one is the one that is this two, that is when you're uploading, you almost directly observe it here. We're gonna go over here, the main topics that we have. You see 3 icons that you see it in here. One is a faint object, one is a bright target. If you're gonna, for example, on the Jupiter and Moon, which one of them is bright and which one is the faint?
Jupiter is bright and the moon
Yeah,
too.
therefore, if you see the Jupiter here, when on the custom observation, you don't see it much detail on the Jupiter. To observe it very bright target to Jupiter, you click on that. When you click it, you see more detail on the surface of the layers of the gas on the planet. Therefore, this helps us that unfortunately the red dark spot is disappeared in last few years. We don't see it anymore. But based on that, you can zoom it in, and when you zoom it in, uh, you don't keep it like that because in the first scale is like that. You don't save it like that. You just bring it and zoom it in as much as detail you can see it and distinguish like this or that. Then you have 2 options for save it. Download viewer snapshot. This is the one, and this is goes to the JPG, and you can see it, save it in any place that you have, or you can export a JPG here. It's gonna be another different form, but you see when you save a JPG, it's gonna save the original one. On the item that we have on the web assign, you have to submit the picture. You always try to do it this one because we don't want to see this picture on there because it shows that you didn't do much work. You didn't zoom it in, you didn't bring it in front. Therefore, it's better recommended for the Jupiter do that way. But on the on the faint planet like a moons, you needed to use this one. Then you use the faint object. You see some of the moons as well. But the problem is that you see a lot of noise on the picture. To remove this noise, you have to use several saturation icon and percentile here. When you have 100 here, you see the bright object. You see, this is similar to the icon bright object here. When you have 95 here, it is noisy and saturation level is 95%. To make it a little bit better, you have to play with this one. You just increase it this one slightly to remove some noise. For example, by the time that you can distinguish still moons and the um, planet, good. See, you see here when you come here, 9982, slightly the moon is disappeared. Therefore, I just play with this one a little better. Probably this one is one of the best option, but there is no single response. You can use any of them is comfortable for you, and then you zoom it in, and you can see it very good. And this is very good to identify the object, and we're gonna show you how to identify those. For this identification, we have to know what exact time the observation is taking. This is the things that happening on the icon show information icon on the right side, as you see it. And here, some of the information is given here, like data, how many pixels are, how many arc minutes are. But other things is that important for us is the time of the observation. You have several time, but all of them is based on the GMT or UTC, Universal Time or Greenwich Mean Time. Therefore, you needed to record this one for your observation. For example, here it shows is 17 of the September 2024. This taking 7:45 GMT or UTC time frame. You don't worry about the second here. It's only if you put it 7 hours and 45 minutes is good enough. You don't need it to other numbers also. And here some other information provided. What observatory is taking the picture? What telescope is used? Prompt 6 on Cerro CTIO. And the filter is used B, and the exposure length is 0.04. The other thing is that we have to look through the, what do you call it, the data that we have. For example, diameter. For example, here, there is, when you click on the hide plotter, it brings some other topics that you have to choose. For example, here, when you click here, centroid clicks, planet centroid, interpolate pixels, and synchronic plot across the files. This is kind of option help us to, for example, if you click here, you click at a random place, but this help us to program. When you click here, if it is click, it could choose exactly on the center. Although I click off that center, but the program choose the center. And when I go to the, for example, age of the planet, age of the planet might be here, or might be somewhere here. It's good enough for us. Therefore, we don't need it to worry about that much accuracy, but as much as you zoom it in enough, it's gonna give you better plus minus tolerance as needed. Okay, sorry, it was get it. I do it again. Oh, probably there isn't here. I have to delete one of those. You have to make sure because when you select the centroid clicks, it centroid only the planet, and 2 points gonna be on the same line. Therefore, you have to play with these numbers to make sure that they are not uh, going to the search rate. And let me see here. For example, I wanna look through the size of the planet. I choose probably the diameter. This is not good. You have to several times try it. Oh, this thing. I have to, yeah, here is better. When you're doing the diameter, you have to unclick centroid and planet centroid because otherwise it may mislead the program. Okay, when you have, this is the graph of the light. As you see it started from here to the end on here, it shows you how many Kelvin, this is kind of temperature on the, what they call it, measurement of the light. And also this is kind of measurement of the arc minutes and arc second that you have on here. Pixel, number of the pixel here. You can change this data later on. But right now, for example, the item that we needed for the data. We only to provide arc second here that you see it here. You don't need it to do anything. Just double click to either side of the planet and identify the arc second, minute, and also get the data from the time and the telescope that you observe here. And then you go back on this kind of lab one. You inform, for example, this is Jupiter. Um, it is observable. Yes, telescope used to, we use the prompt 456, universal time, date, universal time, and the angular diameter that you measured on arc second. And arc second is actually provided here. I remember this is good features. WebAssign has it. When you click on different things here, it doesn't, you don't have to redo it again. The last one that you do it is kept here. Therefore, you can keep it and save and spend less time to do kind of post-processing. This is kind of very measure that we're gonna have here. And then later on, based on the information that we get from Stellarium, and we specify exact time of the observation that we have and check Stellarium to see if it is how much information we get from the measurable contact actually at the time of the observation per Stellarium. That Stellarium for us is kind of resource to get the accuracy and tolerance for our calculation. And remember another item that I forgot to say, this item that you have it here also a little bit different. If you just zoom it in a little bit more, you see it in here a little bit offset here. As long as you just zoom it in proper time, we don't care about this pixel is included or this pixel is not included. The overall scientific work that you're doing here is good enough. And this is one of typical things that a scientist, professional scientist does and do kind of very simple activities on the light and kind of observation that we have. I just stop here. I talk too much. I just have back to you guys. You had any questions? Probably you get on the chat. And thank you, John, for helping us. If you had any question, just feel free to let us know.
I've been trying to drop comments as we're going through this. I've been lagging a little bit, so I know things don't quite
Sure.
correspond, just to kind of follow up what's going on there. And some really good points as we're going through. I'd say in the future, feel free to open up Skynet on your own as we're going through these and try to go through that lesson with us. That's what I had written down real quick. Couple things, going back through all of that. If we open up the Skynet, I'll point out, actually, do you have any questions? That might just direct us. Otherwise, I'm going to go off on a couple things.
Any question?
So when I took a picture of Jupiter, I was seeing like three moons, and your picture is two moons. So like, why is that? Is it because like the moons are on the other side of Jupiter? And how do you
Yeah,
know
Great
which
question.
moons are which?
So we'll get into how to we'll use Stellarium to actually figure out which moons it is because it does a very good job. And that's why finding the time when you did it is really good. Because we can look at the day of the observation and the time of the observation to get an idea where the moons are located. The nice thing about these planets is they're pretty much the same spot all the time. But the moons of Jupiter, they move fast. Like our moon takes a whole month. These moons, we're talking within hours, they've changed their positions dramatically. So you might see two, then you might see five, you might see four. The number of moons, if they're behind or in front, and these little techniques, we learn how to find them if they're in the front from looking at maybe their shadow or adjusting the contrast is the big game when you're trying to do that.
yes.
So you're seeing a different number. That's
Exactly.
what should happen.
Exactly. And also remember that on the one night, if you are clear sky and observe the Jupiter with your telescope or also taking a picture anyway, from, for example, 9, if it is on the sky, Jupiter, from 8 p.m. to 4 a.m., you see all the moons are moving around. And that's one of the key items on the Jupiter and also Saturn as well. Last night, for example, when I observed the Jupiter, I see two moons on this side, but suddenly I see it another moon comes from behind it. And that's kind of very fun activities on the Jupiter. You can easily, in one night, you will see those very easily. I hope you get your answer. Okay.
I'm gonna share
John,
my,
we are
is it
with
okay if
you.
I share my screen real quick?
Yeah.
Okay, come on, go back. I'm in Skynet right now, and when you go to, I'm gonna add a new campaign. I'm gonna put in here the moon, and this was something that came up on Tuesday for a question. I'll make sure you folks get a chance to see this too. So I've got the map over here, the big globe, and when I look at that, I can forward it by an hour at a time, and there's the sun. So nothing's up because we can't do an observation this time. But if I do zip around, since I said the moon will be highlighted, and there it is. Okay. Somebody was trying to make an observation of Mars and they couldn't do it. And that was because the moon was too close to it. And that's one thing to kind of look for is look at where the sun is, where the moon is. Now, if I go back in time, rotate this back, right now we see that Jupiter, Mars, Uranus, this weekend is like the best time. If you haven't put observations in, they'll probably happen pretty quick because right now is a perfect time because the moon creates a sky glow around it. And that sky glow can go out, 30 degrees out from it. So if you're looking for things that are next to the moon, you just won't be able to. It'll be just bled out. But right now we can see that's if you took an observation of Mars, Jupiter, and Uranus, they're in the prime location to get them going. Now, if I do go back a little bit more, there's Venus, Neptune, and Saturn. And it looks like, okay, they're far from the moon too. But now we got to the sun. That's the next thing we're running into. So I know I tried to do observations of a couple of these and it isn't happening. I did get Venus. It is on the cusp. And you might try to take a run for maybe Neptune or Saturn, but it's going to be kind of tricky because they're very close to the sun. And we just realized that there's some of these things you just won't be able to get right now. And I even have my calendar, March 9th. I'm going to go back and look for Mercury because it's finally out far enough you can catch it. But right now, it's right behind the sun. And so we won't be able to catch that. That just won't happen. One other thing I want to point out too is if you look at your files, like do a good job. That open files, that's the first thing you have to do. And then when you get in here, it's going to look like, it ain't going to look like that. It's going to look like this. And the Skynet, that's the one we pick. And then user observations where your stuff is. When we go to save your files, there's different formats. And there was a question about that too. So just real quick about the different formats. All these files are compressed except the FITS files. The FITS files are just completely raw. And there aren't that many programs that will actually open the FITS files. SkyGlow will do it. And there's other ones like JS9, DS9. There's other ones online that NASA uses that'll do it also. But for us, like to save an image you want to kick out into PNG, it won't take as much memory. It does an algorithm thing to approximate what things are, so you lose some information. It's not as clear as clean as the FITS files. So that's really the difference between them, just how much resolution you get as you go. And the FITS actually have layers of information. It isn't just the image, it's more than you'd ever want. Let me see. I'm not sure. Am I sharing my AfterGlow? Let's see. Let me go with the information. This one here. So you see all this information. Is that coming up on your screens? Can you all see that on the right side? Okay. All of this stuff is from the FITS files. This is a layer that's hidden behind the image. It tells you everything you'd ever want to know. And actually, if you go in the FITS files, there's, so much more information in there than just this. So any questions about that? I just wanted to point that out real quick. Should I go into Stellarium, boss?
Yes, you can feel free because I just put it for you to go over on that on this time
Okay.
before end of the session today.
Okay.
Thank you.
So I opened it up. The Stellarium has a couple options. This is the web browser version, which you just put in Stellarium and it pops right up. It's a really fantastic program. You can also download Stellarium to your computer. You haven't heard me say that before. It's good to do, but just download just the basic. Don't be in a hurry to add all the extras on, or your computer will slow to a crawl. possibly. I mean, it can overload your computer. This thing has more information, more stars than you would ever be able to work with. So anyways, I come in, it looks like north. So I'm going to swing this around. So I'm looking south. Oh, there's my planets. And a couple things you can do here on this to kind of get it where it needs to be. Um, it has like log features and all that. And I don't usually use that, but I love this little down to the right. This little button here has a time. This allows you to change the date and the time very quickly. So like if you put down when you did your observation of Jupiter, you could dial back to that date and say, okay, and then get to the time of day when you know that it took it. And then you can look at where is it at? Here it is. So I can pull it up. And I'm gonna go ahead, you can put a search and it'll zoom right on if you want, or I'll just zoom in on this. Now, if you come in on it, what's gonna happen is you'll see all these stars around it, but the moons of Jupiter are so bright that they pop out. And Stellarium will actually show you where those moons are located. Like I'm looking at tonight, I'm like, I need to get the telescope out if it wasn't cloudy, because 1, 2, 3, 4, we got all the moons on the one side here coming out. There they are. And if it looks like they're moving, yeah, it's us rotating, Earth's rotating. It is moving. Um, but if I could actually I could sit on Jupiter. Okay, so there it is. Now if I go back to that time thing, and if I just up the time by minutes, we'll see how those moons are crawling across. Even within an hour, I should see a change in position. There we go. You can see how they just move around the planets. So depending on when you take them and what day and everything like that, their positions completely change. All right, I'm gonna go back to real time. Oh, that's today. Let's get it to tonight. And I'm gonna zoom out. And I'm gonna lose Jupiter if I can. I'm gonna get back out here. Oh, where did I get to? All right, how do I reset this back to real time? And the nighttime, let's go to the evening sky. There we go. Okay, so a real quick lesson about right ascension and declination, because this kind of comes up, is if I aim this thing south, there's Jupiter overhead tonight, beautiful spot. And at the bottom, I'm going to add some lines. So this is called equatorial grid. This line right across here, oh, go away. Here, okay, this line across here is what's called the ecliptic. It's a reference. It's like us looking out from Waxhaw straight out into space, directly over. This would be right towards the sun, the whole solar system's plane, what it's on. But if we look at this, each of these lines here represents an hour. If you take your hand, you put it out, that's the width of your hand. Your hand is an hour hand. It'll represent an hour of sky. And if you take 360 degrees and divide it by 24, you get 15 degrees. So this happens to be 15 degrees also. So the fancy name for the hour part, which goes across, is called right ascension. And I don't know a good reason why it's called right ascension other than it does ascend towards your right. That's how the sky kind of moves as you go through the time. And then we learned, I think last time, that the up and down is declination. And somebody came up with that term too. Oh, the ecliptic. The ecliptic here comes from the term eclipses, right? Was that a boss? I think that was it. Is that you're talking about where the sun and the moon, they eclipsed
Yes, the term ecliptic comes from eclipse because from ancient times in the Greek and before, all the eclipses happen on that line. And because of that, they call it eclipse, the place that eclipses are happening. But is actually more than eclipses, is all the solar system are located on that because at that ancient time, they didn't know about the solar system. Sun is the center.
Yes. And so we look at this, I can see Mars, Jupiter, Uranus, and Venus are actually above the ecliptic right now, but they also will move below. They'll move along this line because they're not perfectly on the plane, right? There's a little bit above and a below. And the sun the same way. The sun will come up across this, and the moon will come across this also. And thankfully tonight there is no moon. If I do bounce it forward, it's a 27.3 days. It's about a 1 month cycle. So realize the moon will move the width of your hand from night to night across the sky. So if I look at the next, oh, I lost my time. Let's go back. There it is. Oh, I did months. Okay, let's go night by night. So night by night, we watch how the planets are moving towards the left, pretty soon here, we're going to see the moon come up, and it's going to, I got to forward the time just a little bit here. Here we go. Okay. There it is. There's our moon. So if you look at the moon each day, it moves about the width of your hand across the opposite direction. So right now, the moon and Mars on March 9th, you couldn't get Mars. Moon is too close to it. That's one hand about apart, about 1 hour or about 15 degrees. I really would have to wait another night or so. And the farther away it is from your planets, the better, or anything you're looking at, the better your observation is going to be. So just realize this little booger is going to get in the way sometimes, and we'll have to make sure you're taking images. If you get a bad image to the moon, realize it's going to take a few more days to take another shot at it so you can get it again. All right, any questions about any of that? Oh, good. It's good. I'm going to stop sharing at that point then.
And another thing I want to emphasize, I forgot that. Let me share it my screen again on the here. Let me see.
As we're going through this, you guys have realized we do Tuesdays and Saturdays, and we're going to try not to blow through things real quick that we did in another session. So we'll try to make sure to honor your questions. If you have questions, please ask.
Yeah,
Or if I
and
speak that don't seem to make sense, ask.
yes, and also remember here when I mentioned, for example, you see it on this time when the picture is taking on for example 7:45 in the morning on the 2024 uh, September 17. It was on the Solar This this is a universal time frame. Therefore, although it shows 7:45 in the morning on the over there, but it's actually in the Solar was nighttime. The another thing is that important to remember here, when you have this picture, when you go to the Stellarium and you see it, the moons are somewhere here. It's not here. The reason is that might be the orientation of the this picture that you're taking by the Skynet and Afterglow is not matched. The only things that you needed to do to rotate, for example, click on here, rotate another one 90 degree, or you just mirror it or you flip it. Therefore, you have to play with these numbers to make sure that you have same orientation that you see it on the Stellarium as well. And that's one of the key things that you needed to do to make sure that when you're comparing this result with the Stellarium, and because later on we're gonna identify, for example, which moon of the Jupiter is. We don't have any idea which moon is that, but we go to the Stellarium and find the Jupiters and we mark it here and save it the data to submit on the second labs on the next weeks or so. Probably in here, as I see it, this is a one moon for sure, but sometimes you have to make it a little bit larger. When I make it larger, it seems to be here. This is two moons are overlapping each other. And also this is very good by this future, or this one also might be. We don't know. And we have to enlarge the stellarium at the same time to see is this is a true or just reflection of the light. That's one thing that I forgot to mention to complete our session here. Any question?
Okay. Hey, we need to say something too also as Skynet. Everybody has access to Skynet. That's not going away or anything like that. But the Cengage, the WebAssign, we've come up with some issues on that. I mean, and Boss deserves a lot of credit. He's trying to resolve things as our understanding of how things are working has changed a bit. We thought initially what was conveyed forward was that everything was covered by the grant and we're good that way. And most of it is. The most expensive parts really are covered. But there is a part that's not. And so I know I was waiting for the WebAssign for the code to go through and for that to happen. And we found out that that's not going to happen. That if you, when you get into the course, the WebAssign is not waived. And that's like a $65 fee to do that. Now, having said that, we've been looking at different options this week and kind of talking it through a few different ways we can resolve this. And for everybody who completes the course, we'll make sure you get a certificate that you've completed it. And as far as you've submitted and you've done what you need to do. And I know we had some people like, am I got to get, is there a big exam at the end or a big test we got to pass? And like, no, 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 no. We're all doing this because we love doing it. And the boss and I aren't getting paid or anything for doing this. I want to learn how to do this as much as you do. And it's just really cool. There's so few people on this planet that know how to do this kind of thing and that know they have this access. You're doing a lot of the same things that professionals, the same tools they use and all that. It's just amazing. Um, but as far as the web the assignments, what I'll try to do is we have different plans. But one is I'll try to kick out like I did in the comments today. I put in all those different settings. We'll try to make sure those shortcuts and keys, those kind of things are kicked out to everybody. And then as far as what tasks to do and any kind of hints you need. And all of the YouTube videos, Professor Dan, they're out there. They're not going away. And you probably found as you find one, all the rest are linked. You can just watch one after the other like that. Okay. And that will get you by. If you want to subscribe into the WebAssign and do that, that's another option. And that'll be like the easiest as far as you want to get a certificate and all that to go through that. And that would be everything's at your disposal. You have access to all the assignments through WebAssign. It's all organized and will work like that. So, Abbas, you want to say any more about that?
No, thank you. Well, as John mentioned, we just talked with Professor Dan WebAssign. This is kind of $65 is related to the WebAssign company itself. It's not related to UNCC, and I think that is kind of missed on the communication in somehow. But because I love that all of you able to access to this, and also John, we just help more effort on that. We're going to provide the two options, track A and track B. And on the track A, you needed to provide access and purchase the $65 for that. But if you are not able to do that, I'm going to send you some information and you just contacted me directly. I will send you that $65 by different way online, either Venmo or kind of PayPal or other option, Cash App. Then you're able to register it and use this as a kind of course. This is kind of very small token for all of us to make sure that have access to that and enjoy the one that we love. And therefore, that's the two options. On the detail, I'm going to send it later on this weekend when I launch it. And also, we're going to provide some information on the additional information that is not on the WebAssign, collected information for the teaching astronomy in broader sense. Therefore, the idea is that you bring you closer to the astronomy and you enjoy it. You do it the things like a scientist does. Therefore, that's the end goal, and hopefully, it is beneficial for you. And when you end the course, as John mentioned, we don't gonna have a fail or pass or no pass exam, but everything you do it, you learn something, you passing along. This is gonna beneficial for all of us and all the community that we live and all our family or friends, everybody. This is kind of improvement on the science, on the society that is, it is our end goal. And hopefully that is beneficial for all of us.
Yeah,
The detail, yeah, the detail on the short, I'm gonna send it to you in the next uh, few hours by end of the Sunday, and my plan I put it in my schedule. Therefore, you're gonna have a process on the either you choose track A or track B, and just don't worry that $65 gonna uh, held you up on that if you had a financial problem.
Yeah, I don't know if you guys realize how generous a boss is being there. That's amazing that he's willing to do that. And I hope you all realize as we go into this, it's really like you're joining a community, a group that we want to see you successful as much as we can as we go through this. And you're really kicking us off. It's nice to think that you'll have these skills and be able to do this thing. Hope it's a lot of fun for you. And I think the hardest part here is getting started, getting your first observations. But I'll have to admit, when those first observations come back to you and you start to see in this stuff and you can analyze it, it's very addictive and it's a whole lot of fun. It's really neat to see what you can do. You folks can do some real amazing science. We're going to try to help as much as we can to support that this semester.
Any question? Thank you, John. Any question? It is 9:58. It's 2 minutes before the end. But also reminding that you have a group me access that John created, and you can send your questions either there or by email to me or John. Therefore, we are more than happy to respond and help you out.
Yeah. If you are finding things that you're using that work really well and you want to drop them into the group me, do that. I've already had a little correspondence with some of the others and some of you too. And feel free though, probably should put those in group me so everybody has a reference to go back to. Like those charts I put it on the side. That just came out of the WebAssign material, Dan's materials. Those are really, really helpful. And I've been playing with those numbers. So those numbers are a good starting point to go from. And I've actually been trying to get better, sharper images of Venus. There's a lot of stuff we can share with you, but I'm just going to be kind of careful because I can throw way too much at you. And we want to make sure that you're at ground level, you're being very successful, and you have a nice slow build on this. Because we don't want this to be very taxing of you this spring. Hopefully it's a fun time and it's something you can do for relaxing and just as having fun.
Yes, and also in addition, as John mentioned, those numbers are initial guide. Therefore, if you find that something, although some of them may take a lot of credit for you, but most of them on the planet is one or two, one credit or two credit or three credit. Therefore, that's gonna be thoughtful, and most of the time also Dan asking all of the student and the teaching assistant if they notice something different, they inform him. That's gonna be a kind of collaborative effort that we can teach and return back and say, oh, this number might be better to this way because of this reason. And that's a kind of collaboration also exists on overall, because right now this course is teaching about 30 or 36, between 30, 40 institutions across the nation. Therefore, all of them contribution may be helpful to make it this course better in next generations. Any last comment and questions? Because we passed 1 minute of the 10, but hopefully you enjoy your time this weekend and keep observing and either by your own telescopes or Skynet, keep us posting if you had a question.
Yeah, well, thanks so much for everybody for joining us today on a Saturday morning, and keep looking up. And look forward to seeing you next time. Reminder: we have Tuesday nights at 7, and then Saturdays at this time 9 to 10, and then Sunday afternoons we do have a catch-up session Sunday 2 afternoon, and that might be a time for some random questions too as we get a little more into the weeds.
Thank you, everyone, and have a wonderful weekend and a clear sky and looking up.
Thank you. Bye.
See you.
Thank
Bye.
you so much. Have a great
You're welcome.
weekend.
You too. Thank you.